This is Unit 4, video number 9, types of reactions. We're going to have 5 types of reactions that are important in chemistry, and we've got to be aware of and know. They are synthesis, which is many to one. Decomposition, which is one to many. Combustion, which is obviously a reaction with oxygen. We're just going to limit it right there. Usually going to have flame, heat, all that, but reaction with oxygen. Single replacement, which is element plus compound. And I'll show an example in a minute of single replacement. The element replaces part of the compound. And then we've had extensive discussion with double replacement. That's our precipitation and our acid-base reactions. In double replacement, we have 2 compounds switch cations. So the cations are going to switch into 2 compounds. Difference in double replacement and single replacement? Pure element. Pure element and single replacement. Okay, so let's look at this. Synthesis, many to one. Here's an example of a synthesis reaction. If I take solid sodium, mix it with chlorine gas, the whole thing's gonna kind of light up real big. I'm gonna get a frosting on the glass that's gonna be solid sodium chloride. Obviously this isn't balanced. We have a 2 here and a 2 here. This is a synthesis reaction because we're combining chemicals producing one chemical. Doesn't matter how many we combine. In this case there's 2, there could be 3. Probably not going to have more than 3 combining, but you could. Usually that's multiple steps. Decomposition is one to many. So if I have calcium carbonate and you heat it up enough, you can drive off the carbon dioxide, you'll get calcium oxide, which is lime, plus carbon dioxide. This is a decomposition reaction. One compound falling apart. So one becomes many, doesn't matter how many. A lot of explosions or one chemical to several, 4 or 5 different chemicals. Combustion is obviously a reaction with oxygen. Oxygen needs to be in the reactants, not the products. So reaction with oxygen. Natural gas is our classic combustion reaction. If the combustion reaction involves carbon and hydrogen, then we're going to get carbon dioxide and water. Generally, combustion reactions make the oxide of the elements that are involved, whatever oxide that would be. Hydrogen's oxide is water, carbon's oxide is carbon dioxide. All right, obviously, 2, and then we're going to have 2. So that's the combustion of methane because oxygen is in the reactants. Single replacement, we said, is an element plus a compound. So if I have aluminum plus nickel chloride, here the aluminum is going to replace the nickel in the compound, and the nickel's coming out as a pure element. So I'm going to get aluminum chloride plus solid nickel. Notice, start with an element, end with an element. Pure element, not a charged species. The aluminum was neutral, became +3. It was oxidized. The nickel was +3, became 0, it was reduced. The last type is going to be double replacement. Double replacement, here we can have okay, so I've got aluminum chloride and sodium hydroxide mixed. Then the sodium and the aluminum are going to switch. Sodium chloride is going to result. Notice, our compound is NaCl, not NaCl3. NaCl, sodium compounds are soluble, that's dissolved. Then we're going to get aluminum hydroxide. All hydroxides are insoluble except for those involving alkali metals and ammonium. So we're going to have here a solid. That's going to create the reaction. If we have aqueous, we have no reaction. So here we've got our reaction. Obviously we need 3 of these, 3 of these, and that's our double replacement. So we've got synthesis, many to one. Decomposition, one to many. Combustion, a reaction that involves O2 as a reactant. Single replacement, element plus compound. And double replacement, compound switching cation.